dot product of vectors. If you have vector A and vector B, then the dot product is A1 P1 plus A2 B2, and the answer is always a scalar. Look at the example in front of you. Pause your screen, solve the question, and compare your answers with mine. Properties of dot product. We start with the first property. When you have two vectors u and v, then u dot v is the same as v dot u. Now, take u dot v, the answer will be 9, and v dot u also, the answer will be 9. Now, we will move to the second property. When you have three vectors, you can distribute basically the multiplication over the sum. This u dot, the sum of v and w is u dot v plus u dot w. Please follow the steps as you can see in front of you. Now, for vector u, if you multiply, you said u dot u, then the answer will be always the magnitude square of u. Now, the fourth property is about multiplying 0 by a vector. The answer will be always 0. Now, if you have number c and you are multiplying by the vector, then you have to notice c times u dot v is the same as u dot cv is the same as c times u dot v. I'm illustrating the example, and you will see in the three columns they will end up having the same answer. The square root of u dot u will always give you the length of the vector. Look at the example in front of you. To find the angle between vector u and v, take into consideration that cosine theta is u dot v over the magnitude of u times the magnitude of v, and then you have to take shift cosine to find the answer. Take the following example. Find the angle between vector u and v. Now, the first step, we will find the dot product between u and v, which is u dot v equal 2 times 3 times 8 times 2 equal 22. Now, the second step, we will find the magnitude of u, which is the square root of 2 square plus 8 square. Third step, we will find the magnitude of v, which is the square root of 3 square plus 2 square. Finally, we will say cosine theta is basically u dot v divided by magnitude u times magnitude v. Then we will take cosine inverse of that answer to find the final answer. Freeze the screen, solve the question, and compare your answers with mine. Two vectors are said to be orthogonal if their dot product equals 0 and the angle between them will be 90 degrees. Take the following example. You're given the vector u, which is 1, negative 2, and vector v, 6 and 3. Now, if you find the dot product, you will discover it's 0. It means they are orthogonal. Example 2. Decide if vector u and v are parallel, orthogonal, or neither. Now, we start with the two vectors in front of you. Now, the first step I would advise you is to take the dot product of them, u dot v. Now, when you calculate it, if it is 0, then stop. It is orthogonal. The two vectors are orthogonal. Now, in this case, the answer is 8. Thus, it's not orthogonal. Now, in order to decide the type of the relation, we need to calculate the angle between them using cosine theta equal u dot v divided by magnitude u times magnitude v. Now, when we calculated, we found theta not equal 0. It has the value in front of you. Thus, it means it's neither. Again, decide if u and v are parallel, orthogonal, or neither. Check with the dot product. If the answer is equal 0, then it means they are orthogonal and theta is always 90 degrees. Okay, a quick tip to find if the two vectors are parallel. If you manage to write one of them as a product between a number and the other vector, then they are parallel. Look at the example in front of you. Vectors projection. Now, when you do a projection of vector u onto v, it's like casting the shadow of vector u on v. I want you to look at the rule. Projection u onto v is basically u dot v divided by magnitude v square times the vector v. Take the following example. Find the projection u onto v given u and v. Now, first of all, we will find the dot product. Then we will find the magnitude of v square. Then we will recall the rule. Projection u onto v is basically u dot v divided v magnitude square times v. We apply the values, then we find the final answer. Freeze the screen and solve the question and compare your answer with mine. Okay, now you can write the vector u as the sum of two vectors, and one of them will be the projection of u onto v. The other one is u minus the projection. Now, take the following example. Find the projection and then write u as the sum of the two orthogonal vectors. Now, we found the projection of u onto v in the previous example. Thus, we will say u1 equal projection u onto v, and we found, as I said, the value before. Now, to find the second vector, you will say u2 equal u minus u1. You will go to the question u is given in the exam, minus the projection. You will do the calculation, and then you will find the value of u2. At the end, you will say, okay, u is basically u1 plus u2. Freeze your screen and solve the question and compare your answer with mine. Okay, let's read the following word problem. John is sitting on a sled on the side of the hill, inclined by 45 degrees. The total weight of John and the sled is 140 pounds. And then he's asking the force that required Raphael to keep the sled from going down. Now, first of all, we will graph a hill, and we will tell you this is John and this is the sled. Now, we will look at John with the sled at the top of the hill, and we will imagine Raphael trying to prevent John from going down. Now, the total weight is minus 140 joule because it's going downward towards the gravity. Now, we will come to the part where he says, okay, he's sitting on the side of the hill. Thus, we will assume a vector called V, and it represents the side of the hill. Now, that vector has two combinations, the horizontal cosine theta and the vertical sine theta. And theta is 45 degrees. Now, after finding the vector V and highlighting that the force is minus 140, we will say, okay, I would like to find the force required. And the force required in this case is the projection of F onto V. We will calculate it, as you can see, according to the values in front of you. Then we will take the magnitude, and the magnitude will represent the required force needed to prevent John from going down. Okay, work needed. When you have a force F that goes in the direction of the vector V, to find the work done, first of all, you have to find the magnitude of the vector V. Then you will decide theta, the angle of the direction angle. And then you will say, okay, work done is basically magnitude F times magnitude V times cosine theta. Work done. To find the work done of a 30-pound force acting on the direction of the vector 1, 2, and it's for an object moving from 0, 0 to 3, 0. Now, first of all, when you have an object move from the origin point to 3, 0, it means he's talking about the vector 3, 0. Now, the magnitude of the force is 30 degrees. We have to find the magnitude of the vector 1, 2, and the work done will be according to the rule in front of you. I'm sorry, I made a mistake in the calculation. I forgot to write the calculation. Just use the calculator and you will find the answer. Thank you. That was the end of the lesson. Thank you so much for watching.